worked a lot already with equations. Math gets much simpler when things are already equal. But today we need to take a look at inequalities. So we can no longer say things like A equals B, only things like A is greater than B. So as usual, let's start by breaking down an example of this. Allie wants to buy her friend Pip chocolate bars. She knows he loves dark chocolate, so she wants to buy him 3 dark chocolate bars. She wants to know how many white chocolate bars she can buy him. If dark chocolate bars cost $2, white chocolate bars cost $3, and she has $15, what number line represents the number of white chocolate bars she could buy him? So before we can make a number line solution, first we need to find the inequality describing our problem. So we're going to do this quickly, but if you're confused, you can look to our video, Creating Equations from Word Problems. Our inequality here is going to be described by how much money she has. So white chocolate bars cost $3 each, and she's going to buy X of them. Dark chocolate bars cost $2 each, and she's buying 3 of them. So that's 3X and $6. Now, she has in total $15, so this 3X plus $6 she's buying of chocolate bars has to be less than $15, and that is our inequality. Now we need to solve our inequality for X. Now, this is really mostly the same as how we do it for equations, and there's only one exception which we'll look at afterwards. Okay, so this will be pretty straightforward, having done it before. So we start by subtracting 6 from both sides, and then after that, we get 3x is less than or equal to 9. Note how we carry the inequality throughout each step. We divide by 3, and we end up with x is less than or equal to 3. Simple as that. Now let's take a step back from this example, and let's look at the one exception that we need to watch out for. So that is, whenever we multiply by a negative number, we need to flip our inequality. Let's look at an example of this. So we know 2 is less than 3, but what happens when we multiply by negative 1? Well, now we get negative 2 is actually greater than negative 3. So we can see this simply when we look at it on a number line. So it's easy to see 2 is less than 3 on the number line, but then we get that negative 2 is actually to the right of, so greater than negative 3. So putting it together and seeing this in the inequality itself, we have 2 is less than 3, and when we multiply this by negative 1, this now has to become negative 2 is greater than negative 3 when we flipped the inequality. So what about a less straightforward example? So instead of 2 and 3, now we have equations with x. So we have 1 over x plus 3. So you may know to solve this inequality, we need to multiply by x plus 3. Now the question is x plus 3 greater than 0 or less than 0? If it's less than 0, then we would have to flip the inequality. If it's greater than 0, then we don't. So what happens when we have something like this is we actually need to split the cases. So the first case is if x plus 3 is greater than 0, positive. In this case, then our inequality stays the same. In the other case, when it's less than 0, we now have to flip the inequality like we did before. So we see the difference in the two cases that we need to break into. So we found our inequality, x is less than or equal to 3. Now we need to look at how to display this on a number line. So let's start with an empty number line. Now we can represent our solution on the number line. So to start, we draw in a circle at 3. So sometimes we fill it in like we do here, and sometimes we leave it unfilled. So let's talk about the difference of what those both mean, what they represent. So if 3 is included in our solution, now this is when we have x is less than or equal to 3, or greater than or equal to, note the equal, so we include that equality. In this case, we fill in. And now in the other case, if 3 is not included, so this is when we have x is less than 3 or x is greater than 3, then we leave it unfilled as we see in this other example. Now, after filling in our point, we might be tempted to just draw an arrow to the left because we have less than or equal to 3 and say we're done. But we also need to be realistic about the scenario. So this solution as we've written it includes all numbers less than or equal to 3. So could we buy, for example, negative 1 chocolate bars? Of course not. So to make this situation realistic, we need to stop the solution at x equals 0. And we can buy 0 chocolate bars, so we fill in that point again. So we see here our final solution, x between 0 and 3, represented on our number line. Okay, great. We found our solution in the one-dimensional case. Now, what about the two-dimensional case? So the example we just did can easily be turned into a two-dimensional case. So let's look at that example. Allie wants to buy her friend Pip chocolate bars. She wants to know how many white chocolate bars and how many dark chocolate bars she can buy him. If dark chocolate bars cost $2, white chocolate bars cost $3, and she has $15, what graph represents the possible numbers of white and dark chocolate bars that she can buy him? So the difference in this new problem is we don't know how many dark chocolate bars we're buying. So the unknowns are both how many white chocolate bars and how many dark chocolate bars. So our new inequality is going to have both x and y, where x is the number of white chocolate bars and y is the number of dark chocolate bars. And it becomes 2y plus 3x is less than or equal to 15. So now we're looking at a two-dimensional problem. So because this is a two-dimensional problem, we cannot represent the solution on a number line like we did before. Now we need a two-dimensional coordinate plane or graph. So we see an example of what that might look like here. So what is our solution graph going to look like? Well, to start, we want to take our inequality and throw it on that graph. So to graph it, we want to first get it into y equals mx plus b form. So let's solve our inequality to get it into y equals mx plus b form. So first we want to move the x to the other side, and then we want to divide the 2 with the y, and we get to y is less than or equal to negative 3x over 2 plus 15 over 2. All right, straightforward enough. Now we want to go and actually graph this equation. If you're not quite sure how to do this, you can look to our other video, Equations of Lines, to break it down step by step. Okay, so now that we have our line, how do we graph the inequality? So we're told that y is less than or equal to this expression, right? So we just shade all the values underneath the line because that's less than in the y, correct? And so we have this shaded area. So we might be tempted to look at this and say, well, we're done, that's our solution. However, like before with the number line, we have to watch out for unreasonable answers. So we can't buy negative chocolate bars, right? So again, we need to cut off x and y at 0. So that becomes these lines here, and when we fix our shaded area, it becomes just this little triangle we see here, and that is our final solution. So putting it all together, you should know how to solve inequalities, as well as how to plot their solutions in 1 dimension or in 2 dimensions. And with practicing these skills, you're one step closer to doing very well on the SAT math section. Hope you liked the video. If you want to hear more and see what else we're up to, hit like and subscribe, and see a new video coming out from Point Avenue every week. If you want to talk to us, hear more about what we're doing, or have any questions, email us at contact@pointavenue.com. Bye!